All right, concept 16, implicit differentiation. On this first one, they just ask for a derivative. They suggest that we use implicit differentiation and express in terms of x and y. So let's go ahead and derive through here. The derivative of 5y with respect to x, we're doing dy dx, so it's respect to x, would have to be 5y prime. Plus the derivative of 4xy, we need to see that as 4x times y, so we recognize the product and apply the product rule. So I'm going to keep the 4x and multiply by the derivative of y, plus this time I'll keep the y and multiply by the derivative of 4x. The derivative of 4x is going to be 4, and I just have the y. The derivative of negative 3 is 0, so I don't need anything there, and then the derivative of 0 is still 0. On the left side, if I take out a y prime, I've got a 5 plus 4x, and at the same time I'm going to go ahead and subtract this 4y to the other side because I don't have a lot of space here. So subtract 4y. If I want to isolate the y prime, I just need to divide both sides by the binomial 5 plus 4x. So y prime is going to equal negative 4y divided by 4x plus 5. Just need to get that to my answer blank. Any questions on this one so far? All right, number 2, we're asked to find dy dx again. They suggest that we use implicit differentiation and again express in terms of x and y. And we said we're going to read this as cosine of xy. So let's see, cosine, the derivative would be negative sine of xy. And then we'd have to multiply by the chain because we have a function inside the sine function. It's a product, x times y, so we need to follow the product rule. So I'm going to keep the x, multiply by the derivative of y, plus this time I'll keep the y, multiply by the derivative of x. The derivative of x is just 1, and 1 times y is just y. Plus the derivative of the x to the 7th would be 7x to the 6th equals the derivative of the y to the 7th would be 7y to the 6th y prime. I'm looking for all the y primes that came out of that. I've got one on the right, and I've got one tied up pretty bad in the left. The only way to untie that one in the left is to distribute that negative sine x y. So I'm going to distribute that negative sine x y. So I've got x y prime, it's actually negative because I'm multiplying negative sine x y times x y prime times the sine of x y minus, distribute that all the way to the y sine of x y. That's I still should have a plus there. I'm going to run out of space on the screen here. I can see that coming. That's plus the 7x to the 6th is still here, and that's going to equal the 7y to the 6th y prime. What I need to do now is get all these y prime things on one side of the equation and everything else on the other. So I'm just going to add this term to the left side. So the right side, I'd have a positive 7x to the 6th left there. I'd have a negative y sine xy on the left still. And on the right, I've still got my 7y to the 6th y prime, but I've added over the xy prime sine xy. Okay. I'm going to factor out the y prime on the right. That'll give me a 7y to the 6th plus x sine xy. And on the left, everything's the same. And now it's just a matter of dividing both sides by this expression that's multiplied by my y prime so I can isolate my y prime. So y prime is going to end up equaling this binomial, 7x to the 6th minus y sine xy, all divided by 7y to the 6th plus x sine xy. That is the final answer for number 2. Any questions there? Okay, number 3 and 4, we're finding derivatives again, this time with logs. So in number 3, the derivative of y equals natural log 4x. If we follow the rule, y prime is going to equal the derivative of 4x, which is 4, divided by 4x, which will reduce to 1 over x. Similarly, for number 4, y prime will equal the derivative of x minus 5, which is 1, divided by x minus 5. Those are pretty quick ones. It's kind of nice after number 2 to have something that's a little quicker. Any questions there? Okay, number 5. We've got a radius of a right cylinder. It's increasing at 9 inches per second. That's the radius. The height is decreasing at 3 inches per second. The question, what's the volume of the cylinder changing? How's that changing? At what rate? When the radius is 6 inches and the height is 8 inches. So let's see. They've given me dr dt, how fast the radius is changing. That's 9 inches per second. They gave me dh dt, how fast the height is changing. That was negative 3 inches per second. And they asked for dv dt, how fast the volume's changing when r is 6 and h is 8. All I need now is a function to work with. We're talking about the volume of a cylinder. Volume equals area of the base times the height, so that would be pi r squared h. I'm looking for dv dt. I've got a v. If I take the derivative, I'll have a dv dt. Equals, I need to recognize that this right side is a product. Pi r squared, one function times h, another function. The derivative, let's see, I'll keep the pi r squared, multiply by the derivative of h, in this case dh dt, plus this time I'll keep the h and multiply by the derivative of pi r squared, which would be 2 pi r dr dt times the h. Now I just have to substitute all the values I have for these unknowns. R is 6, that's the instant we're looking at. dh dt is negative 3. R is still 6, dr dt is 9, and h is 8 at that instant. This comes out to 756 pi cubic inches per second, which is approximately 2,375.044 cubic inches per second. Either one of these answers is fine. Any questions there? Concept 20, we got to find the extreme values, the maxes or the mins. This cubic function, what I'm going to do is I'm going to look for horizontal tangents, so I'm going to look at a derivative. I've got 3x squared minus 6x plus 7. If I check that, I think the vertex is at, what, negative b over 2a would be at 1, right? Negative b over 2a would be at 1, comma. If I put in a 1, don't I get a positive value? Yeah, I get 1. The vertex is at 1, 1, and it opens up, so it's not going to have any intercepts. It's never going to equal 0. So, therefore, this isn't going to have any horizontal tangents, no chance for a max or min, so it doesn't have any. It has no maxes or mins. Again, if we look at the graph on a calculator, we'll see a graph that looks similar to this. So it doesn't have a highest point, it doesn't have a lowest point, it doesn't have any relative maxes or mins either. While we're here, we'll just look at number 7 also. Same thing, if we take the derivative, we've got to do the product rule, or excuse me, the quotient rule. So times the derivative of the top is 2 minus, keep the top, times the derivative of the bottom is 2x. This is the same as 2x squared plus 2 minus 4x squared all over the same denominator. The numerator simplifies to negative 2x squared plus 2, and the denominator remains x squared plus 1 quantity squared. When does a fraction equal 0? Only when the numerator equals 0. Can you see it by inspection when that's going to equal 0? 1 and negative 1. So our potential maxes and mins occur at 1 and negative 1. That's where this first derivative equals 0. If I plug 0 into this derivative, I see the top is 2 and the bottom is positive. So that's a positive. If I plug negative 2 into the function, I see the top is negative and the bottom is positive. So that's a negative. If I plug a positive 2 in, the same thing happens. I get a negative. So my function has the characteristics where it's decreasing headed towards -1 and increasing on the other side. And then coming into 1, it's increasing and then decreasing. So I'm seeing a minimum value at 1 and a maximum value at -1. So I'll say there's a min at -1, comma, and I just plug -1 in and see what I get. If I plug in -1, I get -2 over +2, that's -1. So I have a minimum value of -1 at -1. And I have a maximum at the point 1, comma. If I plug in 1, I get 2 over 2. So I have a maximum value of 1 at the point 1. Any questions on these?